All right, we're back. We're on page 8 of notes 4 of Calc C, and what we're doing is talking about infinite series. We talked about geometric series. We know that those converge if the absolute value of r is less than 1. We know they converge to the first term over 1 minus the ratio. That's if they converge. We talked about telescoping series. The definition of a telescoping series is a series where all but finitely many terms cancel out. So if all but finitely many terms cancel out, they must converge. So to be a true telescoping series, it will converge, and we can find the sum, which is sort of unusual as far as series go. And now we're up talking about some properties and then a couple other things. I don't think this page will take us very long, but I mean, I could talk for 20 minutes about anything, it turns out, so who knows. Properties of convergent series, basically the same as the limit laws, I would say, or definite integrals, like they look very similar. So if we are given that these two series, so a sub n and b sub n, converge to a and b respectively, and that c is an element of the reals, then we have a constant multiple rule, which just says you can factor a constant out of a summation, and you'll just get the constant times the sum. So that's if it converges. And then we have sum and difference rules. It's really important that both of these converge for this to universally be true. If they both diverge, it is not necessarily the case that their sum or difference necessarily diverges, which is maybe one of the most confusing things. We'll get into that. But if they converge, then the sum of a sum or difference is the sum or difference of the sums, which means you just add up, you add up the values you were going to get. So let's take a look at this next thing. So by writing out a few terms of each series, how can you tell pretty much right away that the following series are going to diverge? I don't even think you need to write them out. I mean, I will, but I don't think you need to write them out because, so if I plug in 4, I get 4 over 1, 5 over 2, 6 over 3, 7 over 4. So what's happening here is that these terms that we're adding are not going towards 0. They're actually going toward 1. I'm going to say that the limit as n approaches infinity of n over n minus 3 is equal to 1, which isn't 0, which means that over time, for our sum, we're just going to start saying like plus 1, plus 1, plus 1, plus 1. How could that have a finite sum? It's definitely going to spiral out of control. So this is definitely going to diverge. This one I think is going to be even worse. If I plug in 0, I get 1/4. If I plug in 1, I get 2/5. If I plug in 2, I get 4/6. If I plug in 3, I get 8/7. And I think everything's going to be bigger than 1 after that. Right, so that was 0, 1, 2, 3, like 4 would give me 16 over 8. Yeah, this is getting out of control. Even faster, right? Like now I'm adding 2, then I'm gonna add more than that, more than that, more. So this is definitely gonna go to infinity. And the reason, again, the limit of this is actually infinity. So eventually you're just adding plus infinity, like no way, no chance. This is infinity, which is definitely not 0. Therefore, this is going to diverge. So it turns out that there's actually a property here that says that if a series converges, then the sequence of a sub n, so the nth term, has to go to 0. So the sequence converges to 0. So if the sum converges, then it must be the case that the sequence goes to 0. This gives us another series test. So this is our third series test. And eventually there's a lot of them, but keep up and you'll be okay. This is a series test for divergence. It's the only one we have that is strictly focused on divergence. This cannot tell you if a series converges. It can only tell you if a series diverges. Nth term test for divergence says if the limit, well, basically, if the limit of the nth term is not 0, right? So for a sequence to converge, it means that the limit of the nth term exists and is finite. So what we're saying is if the sequence doesn't converge to 0, so if the limit is not 0, then the series diverges. I try to use this one all the time, if I can. So this is saying that the limit as n approaches infinity of a sub n is not 0. So if the sequence doesn't converge to 0, so if the limit as n approaches infinity of a sub n is not 0, then the series definitely diverges. If the limit is 0, we have absolutely no idea. Might converge, might diverge. We just literally don't know enough yet. And so don't confuse those. So let's see. What do you know about the sum of a sub n? So the series, given that the limit as n approaches infinity of a sub n is not 0, this we know right away diverges, right? The only way it can converge is if the limit is 0. What do we know if the limit as n approaches infinity of a sub n equals 0? Nothing. Which people don't exactly like, but it doesn't matter what you like. So if the limit is 0, no information, try something else, see what's going to happen. If the limit is not 0, definitely diverges, stop there, just write down that it diverges, kind of move on with your life. So don't mess those up. You really have to have a handle on that. And the n-term test for divergence should probably be the first thing that you try no matter what. I mean, think about, even though this, I'm going to write a geometric series. So say we go 0, I don't know, like 5/3 to the n. So I know that this diverges because it's geometric, r is equal to 5/3, which is greater than 1, done. If you totally forgot that, you could say the limit as n approaches infinity of 5/3 to the n is infinity. It's not 0, therefore diverges. So these tests that we're going to learn, you can apply more than one in a lot of circumstances. Sometimes you want to try to apply as many tests as you can think of just to like practice them. So this was geometric. That's the way you should do it. But if you forgot that, the n-term test would help you out here. On the other hand, if we had, I don't know, 1/3 to the n, something like that, the limit as n approaches infinity of 1/3 to the n is 0. Therefore, who knows? You got to do more work. But then you look and you're like, oh, geometric, r equals 1/3, which is less than 1, therefore converges. So you have to know how to apply them, but the n-term test for divergence is a big deal. You're going to use it a lot. So geometric series, telescoping series, nth-term test for divergence. We've got 3 tests so far. Come back in the next video, do some more. Hope to see you there.